Dear students, very good evening. Today we are going to see some problems under Laplace transform using some important results. Okay, problems under Laplace transformation or Laplace transform using some results. Okay, so now to see is L of e power at into f of t equal to f of s minus a. Then the second result we are going to see is L of e power minus at f of t equal to f of s plus a. The third result we are going to see is L of f of t minus a equal to e power minus as into f of s provided t greater than a. So I want to tell you about this result in a deep manner. Okay, this result is very important. So I shall explain you later how this result arises. We have simplified the result. Actually it is a property. This property is called second shifting theorem. Actually these two are first shifting theorem. And this is second using second shifting theorem. I shall explain you later how this property arises. Okay, and there are some more results. There are some more results. The next result is if we are having if L of f of t equal to f of s and there is a constant c greater than 0, then L of f of t minus c along with h of t minus c equal to e power minus cs capital F of s, where this h of t equal to 1 for t greater than 0 and 0 for t less than 0. Okay, so we are going to see the results now one by one and problems related to them. Only one problem we are going to see, only one problem. So first thing, how listen carefully, how to take a note of everything with the kind attention why these properties are important. If not this property, then what will happen to the difficultness that we are facing in solving the problem. Okay, so in that manner you have to understand these properties are very appreciable, which minimizes our time to solve the problem. Okay, so here comes the first problem. So take down a problem. Now I am going to see problem number 1. Find e power 2t sine 3t, e power 2t sine 3t. Now I am going to explain you this problem without using this property, and afterwards I shall explain you the same problem using the property. Okay, so you have to watch very carefully. Okay, you have to watch very. So here they have given e power 2t into sine 3t. First of all, we have to know what is e power ax sine bx when integrated with respect to x. So it is very easy. E power ax divided by both a and b are square, a square plus b square, divided by, we are having sine b, so a sine bx, then minus b cos bx. Okay, if suppose I want to find e power 2t cos 3t, means I will have to use this formula, e power ax cos bx dx, that is equal to e power ax, here also both a and b have to be squared, a square plus b square into, here the first term is cos, so a cos bx, then here it is plus b sin bx. So we have to utilize these two formulas. Here why we are using the integration symbol, because we know that L of f of t equal to integral 0 to infinity e power of minus st f of t dt. So L of f of t equal to integral 0 to infinity e power of minus st f of t dt. So by this we will have, definitely we will have integration. So here comes the solution. Here count the steps and count the number of formulas we want to keep in mind. Okay, now we have to write what is f of t. F of t equal to e power 2t into sine 3t, then L of, okay, this is L, find L of, so L of f of t equal to integral 0 to infinity e power of minus st f of t dt. So here we are having L of e power 2t sine 3t, that is equal to integral 0 to infinity e power of minus st, f of t value is e power 2t sine 3t dt, that is equal to integral 0 to infinity e power of minus of s minus 2 of t sine 3t dt, that is see e power ax sine bx. So here we are having a equal to minus of s minus 2 and b equal to 3. So by this formula, by which formula? By this formula we will have e power of what is a? A is minus of s minus 2 into t divided by a square, that is minus of s minus 2 the whole square plus b square, that is 3 square into a sin bx, that is minus of s minus 2 sin 3t minus b sin a sin bx and b sin bx. So what is b? 3 cos 3t. Now we have to substitute the limit. Now we have to substitute the limit. Here it is infinity, here it is 0. Okay. Now what will happen when you are substituting infinity to e power of infinity is infinity, e power of minus infinity equal to 0. So on substituting infinity, the upper limit will goes to 0. Okay. Now minus. Now we have to substitute the lower limit. The lower limit is t equal to 0. On substituting t equal to 0, e power of 0 will become, anything power 0 will become, I have already given the proof why anything power 0 is equal to 1. So e power 0 equal to 1, so it will become 1 divided by minus of s minus 2 the whole square plus 3 square, okay, into sin 0 is 0 minus cos 0 is 1, so minus 3 into 1, so we will have minus 3. Our final result is minus of minus will become plus 3 divided by see minus of something the whole square. If I take this minus of s minus 2 as x or minus x, what will happen when I square it along with minus? It will become minus x the whole square, that is equal to x square. So there is no need to maintain this minus. So we will have s minus 2 the whole square plus 3 square. That is our final result is L of e power what is given? 2t sin 3t equal to 3 divided by s minus 2 the whole square plus 3 square, that is 9. So this is our final result. This is our final result. If you don't know the property, if you don't know the result, you have to work on this much of steps to attain the results. But now see how our property reduces our work and time. Okay, how our property reduces our work and time. Now I am again going to consider the same problem. Okay, L of e power 2t sine 3t. Okay, now I am going to solve the same problem by using the result. What is our result? L of e power at f of t equal to f of s minus a. So with this result I am going to work on this problem. So here, according to this result, I am not going to take the entire terms inside this bracket as f of t. I am going to take only the sine 3t as f of t. So f of t equal to sine 3t. Okay, then L of e power at into f of t equal to, we know that f of s minus a. Here we are having L of e power 2t sine 3t is nothing but L of f of t. See, I am writing this as L of f of t with s tends to s minus a. I can write it like this. So it will be L of sine 3t, whereas s has to be turned into s minus a. So we will have we know the value L of sine at. L of sine at equal to a divided by s square plus a square. So we will have, what is a? 3 divided by s square plus 3 square with a change of s to s minus a. So we will have L of e power 2t sine 3t equal to 3 divided by this s square has to be replaced with s minus a. So our a is 3. Our a is 3. Okay, s minus 3. So we will have 3 divided by s minus 3 the whole square plus 3 square is 9. We obtain the same result without knowing the formula of e power ax into integration of e power ax sin bx, without integration, without limit substitution, without taking much time, without putting a lot of effort in getting solution. So I hope this will make you to understand how important the result is and why important the result is. Okay, now as I have already told you, I am going to tell you a problem under second shifting property. Dear students, now we have seen a problem under e power of at f of t. For that So for that we are having f of s minus a. In the same way, you can try for e power minus a t f of t. So finally you have to replace f of s by f of s plus a. Very simple. Now I am going to explain 3 and 4. Okay. So for these results, I am going to consider the following problem. So take down the problem. Before that, I shall explain you the property. Okay. The property is called second shifting theorem. I shall tell you the theorem now. I have told you L of f of t minus a, L of f of t minus a equal to e power of, if I am having t minus a, I will have e power of minus as f of s as our result. Okay, this will be our result. I have given the condition t greater than a. Okay, but this have not arisen all of a sudden. This is because of the property or theorem called second shifting theorem. Called second shifting theorem. So in part A you may be asked, what is first shifting theorem? I shall write it here. I have already explained you. First shifting theorem says if L of f of t equal to f of s, then you will have two results. L of e power a t f of t equal to f of s minus a, and L of e power minus a t f of t equal to f of s plus a. Okay, these two results are called first shifting theorem. It may be asked for you in part A. Now second shifting theorem says if L of f of t equal to f of s and g of t equal to f of t minus a for t greater than a and 0 t less than a. Okay, then we will have L of g of t. What is g of t? G of t will have the value f of t minus a if the t value is greater than a. Where you can find a? You can find a here. The term which is getting subtracted from t. Okay. Now for that you will have L of g of t equal to e power of minus as f of s or e power of minus as L of f of t. So I have reduced the whole statement into a simple result, and this result is important. Okay, now under this we are going to see one important problem. See, I am going to explain you the problem in two ways. One is by using property and without using property. First of all, you have to understand what will happen if not the property is used. Okay, so consider the problem. consider a problem on second shifting theorem. Find the Laplace transform of g of t where g of t equal to integral cos of t minus 2 pi by 3 for what is a here, 2 pi by 3 is a here. So we will have condition t greater than a, that is t greater than 2 pi by 3. Here 0 comma t less than a, that is 2 pi by 3. So with this I am going to solve first without using property. If I don't know the property, what will happen? I will use the splitting of intervals. Okay, because see, listen here, we are not going to take it as g of t, we can even take it as f of t also. If you are getting confusions, I will tell this as f of t also, but there is no problem in it. So for your kind consideration, I shall tell it this as f of t itself. Okay, so that you will not get any confusion. Okay, so listen, what is given? F of t. If they have asked in examination for s g of t, means you have to use g of t. So f of t equal to cos of t minus 2 pi by 3 when t greater than 2 pi by 3 and 0 when t less than 2 pi by 3. Now we know that L of f of t formula is integral 0 to infinity e power of minus st f of t dt. If they have given g of t, you have to use g of t here. Okay, see, the formula is existing from 0 to infinity. Okay, existing from 0 to infinity. So our problem will become L of f of t equal to t less than a and t greater than a. So I am writing it as 0 to 2 pi by 3. 2 pi by 3 e power of minus st. What is our f of t for t less than 2 pi by 3? 0. So 0 into dt plus integral. Now from 2 pi by 3 to what is the maximum limit? Infinity. So we will have 2 pi by 3 to infinity e power of minus st. E power of minus st. What is our f of t? Our f of t is cos of, okay, cos of t minus 2 pi by 3 into dt. Okay, so such a big problem. So definitely our L of f of t will become 0. This time is 0. Integration of 0 will return 0. Okay, actually you will have some interval constant, but we are not considering it here. So 0 plus integral this term 2 pi by 3 to infinity e power of minus st cos into t minus 2 pi by 3 dt. So is it possible to solve it directly? No, it is not possible to solve it directly. So for that I am going to use substitution method. So substitutions will be t minus 2 pi by 3 equal to x. Then I will have dt, on differentiating on both sides this 2 pi by 3 will become 0. So dt equal to dx. Okay, now I have to transform the limits from t to x. Okay, transform limits from t to x. So how to transform that? If limits of t are given by 2 pi by 3 to infinity. Okay, so limits of t are 2 pi by 3 to infinity. When I substitute 2 pi by 3 to this t, I will have x equal to 2 pi by 3 minus 2 pi by 3, that is equal to 0. When I substitute this infinity to t, infinity minus any value will again return you infinity. So this is my limit for this problem for x. Okay, now we have to transform that left hand side be f of t itself. Okay, let the left hand side be f of t itself. Actually what you will have here is see, t minus 2 pi by 3 equal to x. So t equal to x plus 2 pi by 3. So you will have L of f of t is x plus 2 pi by 3. This is what you are actually going to have, but there is no problem because finally result will be same. The result is independent of what we are writing on left hand side. Okay, but this will be the actual result on the left hand side. F of t equal to x plus 2 by 3. Okay, that is equal to integral, see our lower limit becomes 0 and upper limit becomes infinity. E power minus st will become e power of minus s into x plus 2 pi by 3 cos x dt will become dx. Okay, now I have to split the exponents into two parts, that is I will have integral 0 to infinity e power of minus s into 2 pi by 3 into e power of minus sx into cos x dx. So what is constant here? E power of minus s 2 pi by 3 is constant. So we can take it outside. E power of minus s 2 pi by 3 outside into integral 0 to infinity e power of minus sx cos x dx. Okay, so you know that when you are having see integral 0 to infinity e power of minus sx f of x dx, what will you write? You write it as L of f of x. Am I right? L of f of x. So in the same way, we are going to write this. Okay, we are going to write this. So the above term becomes e power of minus s 2 pi by 3 into the whole thing can be simply written as L of cos x. L of cos x. That is equal to e power of minus 2 pi by 3 into s into what is L of cos x? What is L of cos x? L of cos t, L of cos x is s divided by s square plus a square. A is 1. A is 1. So we will have s square plus 1 square. So this is our result. This is our result. Okay. So see, if I want to obtain this result without using the property, how many steps we have to do? See, such a big thing we have done. Okay, so I shall again write the statement and the result finally. See, L of what we have given, g of t. So L of g of t equal to e power of minus 2 pi by 3 into s divided by s square plus 1. Okay, where g of t equal to cos of t minus 2 pi by 3. Cos of t minus 2 pi by 3, and this is 0 for t greater than 2 pi by 3, t less than 2 pi by 3. See, I have reduced the entire theorem into result. No. So by that result, we will have L of, very simply we will have L of cos of t minus 2 pi by 3. See, second term is 0. It is not going to be utilized in any way. Okay, so we are utilizing only the first half. So I am writing that alone. So here I will have e power of minus 2 pi by 3 into s divided by s square plus 1, where t greater than 2 pi by 3 is important, because if I put t equal to 2 pi by 3, it will become 0. Cos 0 is 1 and is 1. L of 1 means you will get the result 1 by s. You will not get this result. The entire result will become failure. So this condition is very, very important. Okay, this is what I have given in the result. See, now without using the result or without using the proper second shifting theorem, we have obtained the result. What will happen if I use the result to solve the same thing? See, we know that L of g of t, L of g of t equal to e power of minus as into f of s, where g of t equal to f of t minus a for t greater than a and 0 for t less than a. So this is what our second shifting theorem tells. Okay, so for this we will have so what I have given, I have reduced the entire theorem into a small result. L of f of t minus a, L of f of t minus a equal to e power of minus as into f of t. Sorry, f of s, that is L of f of t. L of f of t or e power of minus as f of s. In both the cases, what is important? T greater than a is important. Okay, so with this result, I am going to utilize utilize the result to solve the problem. Okay, we are again going to consider the same problem. Cos of t minus 2 pi by 3. Cos of t minus 2 pi by 3. So consider a problem. F of t equal to cos of t minus 2 pi by 3. That is our problem. Cos of t minus 2 pi by 3. Cos of t minus 2 pi by 3, t minus 2 pi by 3 and 0. Here we are having condition t greater than 2 pi by 3 and here we are having t less than 2 pi by 3. The question is find L of f of t. If find L of f of t. Okay, this is given. Now I am going to take it as L of f of t. I have given a result now. L of f of t minus a equal to e power of minus as into f of s, where t greater than a. So L of, this is not going to affect the result. So L of cos of t minus 2 pi by 3 equal to e power of, what is a? A is, we can easily judge a. A is t minus a. Here t greater than a. So a is 2 pi by 3. E power of minus 2 pi by 3 s. 2 pi by 3 into s. Cos of L of cos of t. L of cos of t. So that is e power of minus as. What is cos t? Cos t is s divided by s square plus a square. That is s square plus 1 square. That is 1. So our final result can be written as L of f of t or L of g of t. Whatever they have given, you can write that. L of f of t equal to e power of minus as s divided by s square plus 1, where f of t equal to cos of t minus 2 pi by 3 and 0. This is for t greater than a and this is for t less than a. Here it is f of t. We have changed it to f of t, no problem. Here it is f of t. L of f of t. So I hope you have understood how important the property is and why important the property is. On our next occasion we will see or if possible we shall see the another problem also. Okay, for this problem I am not going to explain in ordinary method. I am going to explain only by using the property. Okay, by using the another result. See, find L of e power t minus 2 into so the question is find L of e power t minus 2 into h of t minus 2 this is our question, where h of t is common for all the problems. H of t equal to 1 for t greater than 0 and it is 0 for t less than 0. Okay, so this is what we are having. So by the way, see, we are having a function like this, h of t minus 2. We are not supposed to have any other function like sine of t minus 2, cos of t minus 2. So whatever is given, sine of t minus 2, cos of t minus 2, we can utilize it as f of t. But here we will have some function in terms of t minus c, that is f of t minus c, and along with that we will have h of t minus c. The term itself be h of t minus c. So if I am having like that, how to solve that? So here we are going to take we are going to consider a property. Before that, what is this h? This h is called Heaviside function. Heaviside Heaviside functions. Heaviside functions. Why this function is considered means this by the way, in this function we are having discontinuities, t greater than 0 and t less than 0. Okay, t greater than 0, t less than 0. Instead in the middle we will have t equal 0. So there is a gap in between. Okay, so these Heaviside functions are involved means then Laplace transform will be called as Laplace transform of Heaviside functions, or otherwise it will be called as Laplace transform of discontinuous functions. Okay, Laplace transform of discontinuous functions. In the same way, in the second shifting theorem also we are having the same thing. T greater than a and t less than a. So this is also a example for Laplace transform of discontinuous function. So you have to kindly make a note that this h of t minus e means this h of t is a Heaviside function. This h of t is a Heaviside, Heaviside. So make it here Heaviside function. Okay, so I am going to tell you without using the ordinary method. I am going to use the property to solve this. So solution is here we are having the result L of f of t minus c into h of t minus c equal to e power of minus cs into f of s. So L of e power of t minus 2 into h of t minus 2 will give you the result e power of minus what is c2. So e power of minus 2s into what is f of s. So we have to find f of s for f of t without considering this c. So our f of t is e power of t. Okay, this is f of t minus c. This is f of t minus c, or f of t is e power t. So L of f of t is L of f of t is L of e power t, that is L of e power a t means 1 by s minus a is 1, so we will have 1 by s minus 1, e power of minus 2s into 1 by s minus 1. Okay, so this is our result. E power 8, L of e power of a t is 1 by s plus a. L of e power of plus a t is 1 by s minus a. Now I am going to do one complicated problem here. So can you take down the problem? And this problem is also important for a reference. Okay, now take down the problem. Find L of e power t plus 1, e power t plus 1, okay, into h of t minus 2, h of t minus 2. So this is what we are going to find now. So here also h of t will have 1 0. Okay, now we have to consider this to be in the structure of, see, we want everything to be in the structure of L of f of t minus c into h of t minus c. But here e power of t plus 1 is not in that structure. Okay, so L of e power t plus 1 h of t minus 2 equal to L of f of t minus c h of t minus c. T minus c means it is t minus 2. So c means 2. So c means 2. Now we are going to take this e power of t plus 1 equal to f of t minus 2, because here c is 2. So f of t minus 2 into h of t minus 2. Okay, now I want to have this t to be t minus 2. So I am taking x equal to t minus 2. So t equal to x plus 2. So now it will become e power of x plus 2 then plus 1, that is equal to f of x, that is equal to f of x. Okay, now this entire function is L of f of t minus 2. So this f of x is f of x is f of t minus 2. So In the next step, we are going to find a Laplace transform for. Okay, so we are going to find Laplace transform for this. So we will have I'm having very less amount of space here, so I'm writing here. By taking Laplace transform, we will have L of f of x equal to, this can be split as, see, this can, I shall write it here, this can be split as e power 2 into e power x. So that e square is constant, e square of L of e power x plus L of 1 plus I shall write the below. I shall write it below. So we'll have L of f of x equal to e square L of e power x plus L of 1, that is equal to e square. What is L of e power x? If I want to find L of f of x, so e power a x, so I will have 1 by s minus a is 1, so 1 by s minus 1 plus L of 1 is 1 by s, e square into 1 by s minus 1 into 1 by s. Okay, this is our f of s, this is our f of s. So we have to write it here, which implies f of s equal to e square by s minus 1 plus 1 by s. By the result we must have L of e power t, okay, L of e power t plus 1 into h of t minus 2 equal to f of s. L of f of t minus 2 is f of s into e power of minus es, that is, what is c here? C is 2. Okay, c is 2, so our result is e power of minus that is e power of cs, our c is 2, so e power of minus 2s into e square divided by s minus 1 plus 1 by s. So this is the final result. This is the final result. I hope you have understood the problem very clearly. So kindly take down all the problems. The problems you are discussing are highly important, and you have to know the seriousness of the importance of these problems. Okay, so I hope this video is very important, and you all enjoy the problem, you all understood the problem. Thank you all for watching this video. Thank you all once again. I will catch you up with very important topics and problems in my upcoming videos. Thank you all once again.